Okay, so thanks. The calls are pretty weird. So I'm Jens. And I didn't want to give a lightning talk. When that's for lightning talk, that's me. They're talking about me because, I mean, there never was a lightning talk here because you don't take lightning literally, right? You have to take this word literally. So this is the first real lightning talk at PyCon ever you're going to see because I want to talk about lightning prediction. That's what we do. It's a little pet project I've been doing with a master student who just handed in. And there was one interesting pattern in what we've seen. I'd like to show that to you. Maybe some of you have an idea. Maybe that exists already, but I found it pretty fancy. So basically what we're doing is we look at satellite images. And you have two different satellite images taken from Earth. And you see clouds. And then you can do all kinds of data cleaning on that. But the gist here is you take them at certain points in time, so T1 and T2. And then based on that, you have a model that makes a prediction. Yeah? So the prediction would be at time T3. And, well, when you have a prediction for this T3, you can compare that with the actual satellite images. So basically, we're taking in 3 satellite images in a row, XT1, XT2, XT3. But the model is kind of in the middle. So now I have a prediction for XT3 hat, and sounds like ecstasy a little bit, XT3, and I can make the difference, I can compute the error of the two images, the prediction XT3 hat and XT3, and that's the error, and I feed that in another model. Projector is gone. It's too much physics, too much. Okay, so that's a prediction, and that I feed into another prediction. So that's another model I train. That's called predict2, and that tells me whether lightning occurs, yes or no. So basically, you have 3 satellite images in a row, and they tell you for a point in time, this y hat T4, whether lightning occurs, yes or not. Yeah? And that's a model we've seen. It feels a little bit like boosting, but it's not quite boosting, right? So I don't know. But basically, with that, we get to an accuracy of about 90%. So I mean, the first model is basically optical flow, and the idea here is that it is an algorithm that can predict in 2D the movement of clouds, but it doesn't work in 3D. Thunderstorms and clouds for thunderstorms operate in the 3rd dimension. Yeah, so if anything is going on in the 3rd dimension, the algorithm won't capture that, and that's when there's the error. So we exploit that error to make a prediction for that cloud and whether lightning will occur. So the gist of that is basically that. Yeah, so there's a model 1, you put in the data, get a prediction, and model 2 takes the error of the prediction, compares it with the 3rd satellite image, and gets the actual prediction for the lightning. So that was the first lightning talk at PyCon ever. Thanks.